Today we will be discussing two competing populations and use differential equations in the competing species model to analyze the population size of each and see how they interact with each other. So this model was found in the paper The Lighter Side of Differential Equations, and in this model we have two tribes that exist together on opposite sides of an island. We have a more ferocious tribe, which we are going to call population X, and a more timid tribe, which we are going to call population Y. Now, in order for these tribes to survive, they have to hunt each other for food, so they are both cannibalistic tribes, and we also have to assume that when a member of one tribe interacts with a member of the opposing tribe, that one of them is going to be killed off for food. So we're going to look at this in two different courses. In the first course, we're going to focus on just the tribes alone, and we're going to use differential equations to discover if there's a population size that both of these tribes can hold to create a perfectly balanced relationship between the two. In the second course, an outsider comes onto the island. He's an ecologist, and he attempts to convert the Y tribe to a vegetarian diet. So he tells them, you don't have to harvest population X anymore, you would have lower cholesterol, and you would set a better example for population X. So we're going to use differential equations to discover if the tribe should actually switch over to this vegetarian diet, or if they should just continue on with cannibalism. On to the first course, we have two differential equations, one for each population. Now in both of these equations, the first term represents growth, the second represents overcrowding, the third represents cooperation, and the fourth represents harvesting. So in this context, what we mean by harvesting and cooperation is that as one population harvests or hunts, the other one involuntarily cooperates in that by being the prey. So we can see that population X has a lower rate of cooperation and a higher rate of harvesting, and that's because they're the more ferocious tribe. So we would expect them to be the predator more often than they would be the prey. These second equations just represent a simplified version where the cooperation and harvesting is combined into one term. And then the initial conditions. We're going to start off population X with 50 people and population Y with 1,000. Here's a block diagram. And then our graph. So with these graphs, each axis represents the population size of each tribe in thousands. So we can see our starting point. We start off that population X with 50 people and population Y with 1,000. But the important part of this graph that we want to look at is this end point. So this is our equilibrium point. Again, that's where both of these populations are going to be the same size. So we expect that this spot or this portion would hit the same place on the Y and X axis. So that's hitting at about 3 1/3. So we know that that equilibrium population does exist, and it's about 3,333 people, which is explained here in the conclusions. And we know that this is the population size that both of these tribes need to hold to create a perfectly balanced relationship between the two. On to the second course. Remember, this is when that ecologist comes onto the island and he converts the Y tribe to vegetarianism. So in the short term, what we see is that the X population, we're going to drop that cooperation portion. Everything else remains the same. And then that population Y, we're going to drop the harvesting portion. And we're going to kind of go into why that happened later on. But those initial conditions still stay the same as well. Onto the block diagram. And then our graph. So remember earlier I said that the X population, we took out that cooperation portion, and for population Y, we took out the harvesting. And that's because this happens. So on that vegetarian diet, in the long term, we would expect them to see those benefits of a lower cholesterol. However, in the short term, we can see that the population Y decreases to the point where they hit 0. So that population Y goes extinct, even though X would still exist with about a little bit less than 5,000 people. So that harvesting portion drops out of the Y population because they can no longer harvest if they no longer exist. And then the population X, we took out that cooperation portion because since population Y has gone extinct, they can no longer hunt population X, and therefore they can no longer cooperate in population Y's harvesting. So in conclusion, we would know that in the long term, they probably would see those benefits of the vegetarian diet and they would have a lower cholesterol. However, in the short term, population Y would go extinct. So it can be concluded that the tribes would not benefit from that vegetarian diet and they should just keep on with their current cannibalistic diet. There's our reference.